Hello, calculus fans. Now the terms of the series we're testing has to be smaller than that of a known convergent series or larger than that of a known divergent series. So how about this series? Sum of 1 over 2 to the n minus 1. Now the intuitive thing to do is to try to compare it with the sum of 1 over 2 to the n, because that's a convergent geometric series. The ratio is 1/2. The problem is the series that we're interested in is bigger than this series. That doesn't help when we want to use the comparison test. The inequality is going the wrong way. So in order to handle this, we have a more sophisticated version of the comparison test. All right, so the theorem is the limit comparison test, which I'm now going to abbreviate as LCT. Let's suppose that the sum of a sub n and sum of b sub n are positive term series. And if we take a limit of a sub n over b sub n, as n goes to infinity, and we get some number L, as long as L is a finite number that's bigger than 0, then both series have to behave the same. The conclusion is similar to that of the integral test, except we don't have to deal with any integrals here. All right, let's go back to the series that we started with, the sum of 1 over 2 to the n minus 1. We'll compare it to the sum of 1 over 2 to the n. So we're going to let a sub n be equal to 1 over 2 to the n minus 1, and b sub n be equal to 1 over 2 to the n. All right, let's look at the limit of a sub n over b sub n. That's limit of 1 over 2 to the n minus 1 all over 1 over 2 to the n. Flip things over and multiply, and then divide top and bottom by 2 to the n. We end up with a limit of 1, and remember that in order to use the limit comparison test, we needed to have something that was between 0 and infinity. Now the series that we're comparing to converged by the geometric series test, so we conclude then that the sum of 1 over 2 to the n minus 1 converges by the limit comparison test. Okay, that's all for now.